So applications of derivative was the name of a chapter which we covered one part called as increasing or decreasing functions. Yes or no? Clear? You know very well increasing when differentiation is positive. First differentiation is greater than 0 or positive. It's called an increasing function. And first differentiation less than 0 or negative is called a decreasing function. We know that algorithm, right or not? Fine. Now, particularly from applications of derivative, why I am insisting on this, understand this. From applications of derivative, yes, first is increasing or decreasing functions. Okay. Clear? So, second, important maxima and minima. Third, tangent and normal. Clear? In general, from these topics, three topics, 5 questions come. One question from tangent and normal, 2 questions from maxima and minima, and 2 questions from increasing and decreasing. Clear? Sure. There have been scenarios when the question from tangent and normal have not been observed. But in that paper, there were more questions from maxima and minima or increasing and decreasing. So, on a whole, 5 questions are going to come from what we are going to discuss. Clear? Sure. If you are following what I am recommending, with that strategy, if I have to attempt the paper, as soon as I get the mathematics paper, my first shot, see, if I have section A, God wants me to pass the exam. Not the case that if you do not get set A, then we are not in a good scenario. No, God always has blessing on you. But special blessings are there, right? Clear? When you have set A. Why? Because topic wise arrangement is there in set A, then you do not have to keep on shuffling the paper. In that other scenario or with section A, excluding everything like that, statistics plus probability is my first shot. Okay, clear? 15 odd questions are there, out of which in hustle and bustle also if I do, I should be able to do 10 to 12 questions. Understood? If I am writing the paper, I am saying that. Clear? My first shot will go toward this. Okay? Sure. Now, second, इसके बाद I become independent. This is a must to do. Statistics and probability is a must to do. After that, basis on the level of preparation, we have to escalate. Like, ready? So, if this takes 30 minutes, then fine. The second shot I will give is to the chapter called as matrices and determinants. Or if your coordinate geometry is strong, you can also prefer two-dimensional coordinate geometry and three-dimensional coordinate geometry. Matrices and determinant also give you 14 odd questions. 2D and 3D combined give you 18 questions. Okay? Fine. When you do that, another 30 odd minutes you should be able to do 10 more questions is what I feel. I'm going very slow only. No fast movement as of now. So in first 1 hour, you should be somewhere between 20 to 25 questions. Clear? Then you are left with 90 minutes. And you have to hunt 30 questions. Here your speed will go down because you have to select some questions. Okay? Sure. What you can prefer here is calculus. Differential calculus will bring you 12 question, easy question. Other part of differential calculus are very simple and do not take much of your time. Only AOD takes some of your time. Clear? And then out of these two, whichever you have selected or not selected, on to you. Understood? Now in between this, I will, after like a day or two, second or third is Good Friday, I guess. So on that day we will have marathon class. So I will show you how to read a paper, approach a paper. You can understand many very easy topics I have not even mentioned. I have only mentioned thick bandwidth topics which are going to give you more than 10 questions. Clear? Even in last 10 days you revise these topics only, then you can go to a very good stage. Everyone clear? Sure. So we will keep on discussing about it in later stages as well, bringing you back to maxima and minima. Okay, bringing you back to maxima and minima. Sure. And listen, it's very important. So see, ready? If I observe sine and cos, we know this is increasing, y dash is positive, some y dash is positive, we know it. Clear? So the function is increasing. Clear? In this area, y dash is negative, the function is decreasing. We know this. Yes or no? Right? Now, in between these two nodes, you might have observed that there comes 2 points where if I draw the tangent, it will go straight. Yes or no? Y dash is 0. Clear? Sure. So the points where y dash is equals to 0 are called critical points. Are called what? Critical points. Why critical? Because they are the points where the function will have its maximum or minimum value. Clear? We do not know which value. They are critical. It can be maximum value or minimum value. We do not know. For confirming that, we have another step. Okay? I am discussing as if you are going through this topic for the very first hand to keep a very good balance of concept and clearance. So understand. First step is calculate y dash, put it equal to 0. You will get some values of variable. Clear? These values are called critical points. Understood? Second, Then you do the second derivative, y dash, and put critical points, CPs, critical points. Y dash equal to negative implies that critical point is maxima, and y dash equal to positive implies that critical point is minima. Clear? And I am now putting it on silent so that I do not get distracted. Sorry. Note here. I'll explain you the case. Let's go by our knowledge. By our knowledge, we know that this is the graph of sin x. Yes or no? We know that from 0 degree to 360 degree, at x equal to 90 degree and at x equal to 270 degree. X equal to 90 degree is maxima and max value is 1, and x equal to 270 degree is minima and minimum value is -1. We know this. As of now, we haven't applied a derivative to it. We know it by trigonometry. Yes or no? Clear? Now, how to know this for a function by using differentiation is what we are learning. Are we with each other? Are we together, guys? Someone respond that we are connected. Good.
Okay.
So, what we will do? So, we will say, sir, first step is whatever the function is given, find its differentiation, which is cos x in this case, and put it equal to 0. We know that cos x is 0 in two cases. At x equal to 90 degree cos is 0 and x equal to 270 degree cos is 0. So these two are the critical points. I am writing CP1 and CP2. Yes or no? Clear till critical point? Good. Second. So now I am redifferentiating. Differentiation of cos x is negative sin x. So the value of y double dash at CP1 is negative sine of 90 degree, which is coming -1, and the value of y double dash at CP2 is negative sine of 270 degree, which is coming +1. Implies that this is a negative value, which tells you that x equal to 90 degree is maxima. Understood? There is a positive value which tells you that x equal to 270 degree is minima. Clear? Now for minimum value, put maxima in the equation. So when I put maxima in the main equation, I get the max value, which is +1. Clear? And if I put for minimum value, put minima in the equation, what will I get? When I put 270 degree in the equation, I am getting -1. This is the minimum value. Understood? Yes or no? This is the algorithm. Clear? Sure? Ready? So now my question is, Suppose there is a function y is equals to x square minus 3x minus 6, and I want you to find its maxima and minima, and hence maximum and minimum value. So what will you do? You will say कि sir, the first thing we have to do is y dash. It is coming sir 2x minus 3. Putting it equal to 0, we are getting x equal to 3 by 2. Oh sir, we only have one critical point. It implies it will only have a minima or it will have maxima. We do not know whether it will be minima or maxima. For checking that, yes, we have to do the double dash. Our answer is 2. Without even putting y double dash is coming positive, imply it is a case of what? Minima or maxima? Case of minima or maxima? Minima. Yes. So it is a case of minima. So x equal to 3 by 2 is minima, and minimum value is when I put x equal to 3 by 2 in this equation. Yes or no? 9 by 4 minus 3 into 3 by 2 minus 6 comes out to be 9 by 4 minus 9 by 2 minus 6. 4 is in the denominator. Clear? 9 minus 18 minus 24. You can get the answer very easily. How much? Negative 33. Clear? Understood? Negative 33 by 4 is the minimum value of this function. Clear? X square minus 3x minus 6. I will show you also. So y equal to x square minus plus था plus minus 3x minus 6. See, so this function do not have a maxima. Maximum goes to infinity. Yes or no? But it has a minima. At what point? Its value is at x equal to 3 by 2, and its value is minus 33 by 4. Na? Got that point? Yes or no? The lowest point of the curve. The lowest point of the curve exists at 3 by 2, 1.5. And the value of the lowest point is 33 by 4 negative. Understood or not? Clear? Sure? Understood? Good. ठीक ठीक. ये क्या हो गया? अपडेट पे चला गया यार मेरा वन नोट तो. Understood? Yes or no? Now from here there comes 3 types of question. How many types of questions? 3. They are, what I am using are not going to be the official names because no one says that, but I have myself only my own creation. I have started using these words. Okay. So the 3 variants of the questions are: one is straightforward question. Okay, like what we just had. The function will not be as simple as just given. It will be a bit complicated, but straightforward. Find the maxima, minima, or maximum value or minimum value. Clear? Second, local maximum and local minimum value. ठीक है? LM I call it. Fine. Local question. and third is boundary condition. I'll explain three, don't worry. First one, have I explained? Right? Whenever a function is given and they are asking maxima or minima, the easy thing you do is you do the first differentiation, put it equal to 0, you get critical point. One or many. If one implies that it will only have one maxima or one minima. Clear? Many depends. Okay? Clear? Now comes local maxima, local minima. I'll explain what I am saying. Suppose a function looks like this. Understood or not? Clear? Now at what all point tangent is parallel to x-axis? So you will say कि sir एक ये point है, 2, 3, 4. Clear? So when a function has multiple critical points, okay, they are termed as local maxima and local minima. I will give you an example. Suppose there are two sections. From here to here is section A, and from here to here is section B. Understood? So you can see in the section A, there is a lowest and highest performer. Yes or no? Of its own. And in section B also, there is a lowest and highest performance of its own. Right or not? So for section A, the lowest and higher maxima and minima are local maxima and local minima. And for section B is local maxima and local minima. Understood? Clear? Yes, that does not mentorize when I say one maxima is, suppose this is P1, this is P2, this is Q1 and this is Q2. Critical point are P1, P2, Q1, Q2. All four are critical points. At P1 and P2 double derivative will come as negative. At Q1 and Q2 double derivative will come as positive. Yes or no? Then at last you have to compare them, and then finally only you can tell whether which one is actual maxima and actual minima. Otherwise they will be called as local maximas and local minimas. Are we clear? Understood? So if UPSC will have to give a comprehension based question, they will give from here. Clear? What I have observed is many a times UPSC doesn't bother only using the word local maxima and local minima. They play in domain. I'll explain how. Ready? So you will say, for very obvious reasons, '90 and 270s are the maxima and minima for sin x. Yes or no? But if I say, listen to me what I am saying. If I say y equal to sin x, where x is between 30 to 120 degree, then the story is different. Yes or no? Will 270 even exist in that case? No. Clear? Understood? So at times UPSC does not even use the word local maxima and local minima. They want you to understand by looking at the domain. So any maxima minima question which is coming with an added domain, be very clear while reading the domain, whether it is a general domain or it is a cutted domain. Understood? If it is a cutted domain, it is going around maxima and minima. Are we clear? Or local maxima and local minima. Are we clear? Other part of the question remains very same. Like how? Same process, y dash, you will get cos x, you will put equal to 0. Once you get equal to 0, you want two answers. One is x equal to 90, one is 270. But 270 is not coming in there. You will say only one case here, 90 degree. Clear? So this function will only have a local maxima. Fine? Good. Proceeding. Back. Important and confusing. Important and confusing. Boundary condition. So understand. Hard note. If while giving you a function, UPSC says x belong to close intervals, when this part is used, okay, and no CP comes, what I am saying, no critical point comes between A and B. Between A and B, no critical point is there. Then 99%, 100% only, I want to just keep myself a bit safe. Whether 99.99% germs, right? So, in that case, A and B are the local maximas or local minima. A and B are the locals. You know locals kya hai, what is that? Clear? In that case, your tests will not work. Suppose you got y dash, okay? So, equal to 0, x equal to c, suppose c is less than a. Then is c between a and b? No. Clear? The critical point is coming less than a. Then critical point is not between a and b. Then you say, okay, if that be the case, then let me test directly by putting the value of a in the function and b in the function and get me the answer. Clear? Sure. Again, same example. So if I have given you this function, there are perks of being in Jammu. अभी मेरे सामने एक कॉम्बैट चॉपर चीता लैंड किया है, अब भी थोड़ी देर पहले, अब वो टेक ऑफ कर रहा है बिल्कुल सामने, एंड बिहाइंड मी इज द Tavi river flowing. I can hear the sound of the river. I can hear the sound of the river flowing. There are perks of being at mountains. And in that condition, I am motivating myself to teach you by somehow arranging the internet. So see, you have to be motivated. Clear? Chalo, back to agenda. We know 90 and 270. But suppose I give you a question y equal to sin x, where x belong to 30 degree to 60 degree. Then you are like, sir, 30 degree यहाँ है, 60 degree यहाँ है, sir, ये है बस. So you know that. When you will solve y dash, you will get cos x. And when you put cos x equal to 0, when you will put cos x equal to 0, सजी हरिओम सजी सजी अभी मैं ले रहा हूँ सर जी, AOD खत्म कर रहा हूँ. हाँ ठीक है सर जी. आप तो नहीं, मेरे को लग रहा था क्योंकि आपको वहाँ की क्लास संभालनी पड़ेगी, राइट सर. तो अब आप मान के चलिए कि कल भी मैं शायद मैनेज कर लूँ. कल मैं आपको शायद 8 बजे के लिए डिस्टर्ब करूँ, राइट सर, 8:30 बजे के लिए. गुड फ्राइडे के दिन सर हमें इनकी लंबी क्लास लेके एक चीज़ खत्म करनी रहेगी, वो हम डिस्कस कर लेंगे, राइट सर. मैं कल आपको पूरा कंफर्म बताऊंगा यहाँ क्या है और कितने दिन होंगे, राइट सर. ठीक 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 है, हरिओम, थैंक यू. हाँ भाई वापस. So when you put cos x equal to 0, you get 90 and 270. Both do not belong to this area. Then what you do? You directly put sin x 30 degree 1 by 2 and cos x 60 degree root 3 by 2. So they become your local maxima, in this case is 60 degree, and local minima in this case is 30 degree. Understood? Clear? So whenever there is a x belong to and you have scenarios of closed interval, then the boundary points are itself maximum and minimum. Clear? Sure. Are you able to hear the chopper sound? Is chopper sound coming? No. फिर आया है इसे सुनो. चलो, ready? So maxima minima clear? Should we do the questions? Relax. Though I did collect a PPT. We have to see where are the maxima and minima questions here. Okay. See, look, first question, local maxima, local minima. Visible? Read it. So a differential function f of x has a local maximum at x equal to 0. Clear? So the function is given to be this. Which of the following is or are correct? Clear? So the means whether maximum or minimum, x equal to 0 is one of the critical points. Yes or no? And for critical point, what do? We differentiate. So 2 times f dash x plus differentiation of ax is only a, differentiation of b is 0. Yes or no? Sure. And it is given that 2f dash 0 at x equal to 0, it will be 0 plus a is equal to 0. Yes or no? Clear? Right? Now, which of the following statement are acha, they are only talking about f, then we don't have to be bothered about differentiating. The whole y is not required. We have to only concentrate on f of x. Understood? See, they do not want y, they want what? F of x. Only f of x. So if at x equal to 0 it has a maxima f of x, then f dash 0, can you read this? First line, f dash 0, it is written f dash 0 is equal to 0. So first part is correct. Yes or no? And because of maxima, second derivative at x equal to 0 will be negative. Is this also correct? The straightforward question. No variation. Clear? Good. So first question, they did not discuss anything about y. Straightforward question. Which of them are correct? Both of them are correct. Yes or no? Good. Second question I am writing. The function y has a relative maxima. Okay? Sure? So we do not know how many points. Why? Relative is local. Okay? So now they are talking about y. Second question, 84, they are talking about y. So, for having a maxima at x equal to 0, first differentiation of y, which is this, has to be equal to 0. Means f dash 0 has to be equal to negative a by 2. Yes or no? Clear? Fine. Second, for having again same maxima, the second derivative of this part, this one, What is the second differentiation? 2 as it is. F double differentiation of x. Differentiation of a is 0. This has to be less than 0. Yes or no? Right? Now in both the expressions, is there any participation of b? The value b? Is there any participation of value b? No. So, for all B should be the right answer. Clear? Okay. And already in the first question we have f dash 0 equal to 0. Yes or no? So from here, is A not equal to 0? So the right answer is understood. Clear? Good. This was a straightforward analytical question. '81 and '82 are the questions from the same stanza. Look at this. Same paper. See, 2024, 4 questions came. Yes or no? 1, 2, 83, 84 and 81, 82. Yes or no? Read the question. So they have given you the function x is greater than 1. That is basic definition of log. Clear? Because log 1 will be 0. In this case, denominator cannot be 0. That's fine. Okay? Are we clear? First question is asking about increasingness and decreasingness. Let's do that. Because anyway for maxima and minima also we will have to do first differentiation. Yes or no? Right? So first differentiation is denominator as it is differentiation of numerator minus numerator as it is differentiation of denominator whole divided by square of the denominator. Are we clear? So if I simplify, I get log x minus 1 by log x square is my first differentiation. Yes or no? Clear? So f of x is increasing in the interval e to infinity. So when I put log e is 1, so at log e it is 0. Any value of x which is greater than e will give you an answer more than 1. So it will be positive. So for x greater than e, f dash x is greater than 0. Implies increasing is true. Clear? And similarly, second answer is also true. For x less than e, the value will come negative. So it is decreasing. This is also true. Yes or no? Clear? Now the third question. Look at it. Make it look like the function. So x and log x should be there. So if 9 is there, below 9 should be log 9. Keeping the sign same. 7 is there, below 7, log 7. Yes or no? Did you get it? Is this statement true or false? How will you tell? So your answer is there in these two lines. Sir, as they are more than E. E is 2 point something, around 2. Okay. Sure? So 9 and 7 are more than. So after E, the function is increasing. Yes or no? Means the value of the function at 7 will be here and the value of the function at 9 will be more. Yes or no? Means this statement is true. The value of the function at 9 will be more than the value of the function at 7. So this statement is also true. Clear? Which of the statement are correct? 1, 2 and 3 are correct. Clear? Good. Remember the differentiation log x minus 1 of log x whole square, okay? Because that will be of use. Now second question, f double dash. So we are like, okay, we know that f of x is log x minus 1 upon log x whole square. Clear? F double dash e is equals to 1 by e, we have to calculate. So ready for redifferentiation? Just lengthy, I shared with you. It will not be difficult. It may at times get lengthy. Okay. So I am doing denominator as it is, differentiation of numerator minus numerator as it is, differentiation of denominator whole divided by denominator squared. Okay, clear? What we have to put? We have to put x equal to e. So as I put x equal to e, what do I get? Look here. 1. Yes or no? Log e is 1. So 1 square gone. 1 minus 1 0. This whole tabba gone. Here I am getting 1 by e in the numerator. Denominator log e is 1 to the power 4. So this statement is correct. Yes or no? Good. It is saying f of x attains local minimum value at x equal to e. So at x equal to e, the second derivative is coming positive or negative? This is positive or negative? Positive. E is a positive number, right? Means it is the case of minima? Yes, correct. Now what is the local minimum value? For that we have to put in the main function. F of x by definition was x by log x. So when I put x equal to e, I get e by log e. Log e is 1, e by 1 is 1. This is also correct. Which of them are correct? 1, 2 and 3 are correct. Clear? Yes or no? Understood? 4 question, 10 marks, straightforward. If you invest 3 to 5 minutes. Okay, I am explaining also, hence it is taking time. Fine? Clear? Oh my god. Maximum and minimum again. See, 2014, 24. So 5 question. Ready? I will not solve this. You guys solve. It is basis of direct question. The non-negative value of b for which the function, this is the function, cube x square and x are there, okay, has neither maximum nor minimum in the range x equal to x greater than 0. So you will say, sir, for that the critical point should not come anything x greater than 0. Yes or no? Yes or no? So your answer is, sir, differentiation 16 by 3 x cube is 3x square minus 4b x square is 2x plus 1. Clear? Fine. Now there is a equal thing here. I'll just try to put b equal to 0. If I put b equal to 0, this part gone. our actual expression is? Yes or no? This is our y dash. If I put, right, b equal to 0, do I have the answer? So when I put b equal to 0, I get 16x square plus 1. Can it ever be equal to 0? Can it ever be equal to 0 for any real value of x? Imaginary value, yes. Can it ever be 0? So b equal to 0 should be there. Is b equal to 0 here? No. 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 Answer is delta. Understood? Clear? Options will help you out. So these were 5 questions of 2024-1 from Maxima and Minima and increasing and decreasing combined. Clear? Now you guys try. Take your time. 79 I'll do. 78 you guys do. 79 I'll do. Meanwhile, I'll get myself a glass of water. 78 you do. So for critical point, I have to put y dash equal to 0. For finding y dash, I have got two ways. One, I will convert this equation in the form of y equal to f of x. Standard rule. We can directly also differentiate, but I will convert. Y equal to 9 minus 4x square or y equal to this. Are we ready? Now y dash is 1 upon 2 root 9 minus 4x square, differentiation of minus 8x. Clear? If I want this to be equal to 0, x equal to 0 is my only answer. Is there any other answer? No. So I have only 1 point. And 1 point means whatever they are asking. So if I put x equal to 0, I get y equal to plus or minus 3. They are asking maximum value. So plus 3. Ready? Good. Now they are asking what is the maximum value of x into y. Understood? What is the maximum value of x into y? How will you find x into y? Maximum value of x into y. So you will say, sir, x into y can be written as x root 9 minus 4x square. Are we clear? Same. Hence I said that I'll do. Okay. Now the differentiation will be a bit lengthier. Let's try differentiation. First as it is, differentiation of second plus second as it is, differentiation of first. Yes or no? Clear? Ready? So if I want this to be equal to 0, may I erase the upper part because I need space to solve? Look here, just a bit lengthy, nothing else. LCM gone here, gone with 0. Clear? And 2 and this become negative 4. So negative 4x square plus, when this goes here, square root opens, it is 9 minus 4x square again. Yes or no? This has to be equal to 0. Implies that 9 equal to 8x square or x should be equal to 3 by 2 root 2. Yes or no? Plus minus. Right? Okay. For x equal to plus minus 3 root 2, 3 by 2 root 2, if I put here, I get 4 into 9 by 8 plus y square equal to 9. 4 2s are, so y square equal to 9 by 2, y equal to 3 by root 2. Yes or no? Clear? So they wanted x into y maximum. So x is plus minus 3 by 2 root 2, y is 3 by root 2, 9 by 4. Yes or no? Yes or no? Clear? Just that this is a bit lengthy. That's it. Nothing else. No variation of concept and all. Concept remains the same. Clear? Okay. Do it again. The 79th part. अभी करो. Solve it again. Hmm. In these kind of scenarios, my recommendation is not to differentiate the matrix, rather expand it. Ready? It will take 1 extra minute maximum, less than 1 only. So, x plus 1 into x plus 4 x plus 9 minus 36. Negative 2 into 2x plus 18 minus 18. Positive 3 into 12 minus 3x minus 12. Clear? Expanded? Yes or no? You can see 12 and 12 got cancelled, 18 and 18 got cancelled. X plus 1 into this part is x square plus 13x plus 36. So 36 got cancelled inside. X square plus 13x. Minus 4x visible, minus 9x visible. Yes or no? Clear? So if I expand further, with x I have x cube plus 13x square. With 1 I have 1 more x square, so 14x square plus 13x got cancelled. So my actual expression is x cube plus 14x square. Yes or no? Right? Now we have to say increasing, decreasing. 76th question. Well, like sir, first differentiation equal to 3x square plus 28x. Yes or no? Right? Okay. The function is decreasing on. So if I put x equal to 0, is it coming positive or negative? 0. It is coming 0. Yes or no? So these two are the areas. These two are the areas. Right? Clear? So in this area comes negative 1. In this area comes positive 1. If I use positive 1, I will get a positive differentiation. Decreasing, no. Yes. Clear? For differentiation, negative. That is decreasing. The function attains local minimum value at. So we know that it has two critical points. When I put it equal to 0, I'll get x equal to 0 or x equal to negative 28 by 3. Both. These two are the critical points, but we do not know whether they are maximas or minima causa. So for that we will redifferentiate. Double differentiation is equal to 6x plus 28. They want minimum, means double differentiation should be positive. At x equal to 0 it is coming positive, so the right answer is C. Clear? If the same question would have been maximum, the right answer would have been this. Clear? Good. See, 2023, 4 questions are already there. Clear? In this set, I haven't included tangent and normal, so we are not looking at the tangent normal question as of now, right? This is an important question. I'll solve. I want to give you one question to do yourself, then I'll go into these questions. ये तो मजेदार है. A function vanishes means it is equal to 0. So the derivative of this is equal to 0 at x equal to 2. Then what is the value of m plus 8n? Solve this question, then I'll go to the questions below this. For your information, differentiation of 1 by x is negative 1 by x square. Should I? Just for verifying your answer. So differentiation of this function will be m as it is, negative 1 by x square plus 2n as a number, differentiation x of 1, right? Okay. At x equal to 2. So if I put x equal to 2, I get negative m by 4 plus 2n equal to 0. Means negative m plus 8n equal to 0. Cannot be determined due to insufficient data. Clear? Okay. If they would have asked what is the value of negative m plus 8n, then the answer would have been 0. But they are asking positive m plus 8n. Okay? Sure? Sure. Next question. The other questions which are important. Particularly the mod one. अच्छा ये क्वेश्चन देख लो. Under which of the following condition does the function attains maximum value? How will you solve? Should I solve? Or you are solving? Chalo, let's solve together. So for that, differentiation should be 0, critical point. So first differentiation is p square as it is, differentiation of secant square x. I can write secant square x as 1 plus tan square x. Not required, I can directly also differentiate, but take. Okay, if I do so, differentiation of 1 is 0, differentiation of tan square is 2 tan x secant square x plus q square as it is. Cosecant square can be written as 1 plus cot square x. So differentiation is 2 cot x negative cosecant square x. Yes or no? And this has to be equal to 0. Are we clear? This is 2 tan x. Fine. Critical point means this negative goes that side. So p square 2 tan x into secant square x equal to q square 2 cot x into cosecant square x. Better we convert everything into sine and cos. So 2 and 2 already got cancelled. P square sine by cos 1 by cos square equal to q square cos by sine 1 by sine square. Yes or no? Clear? gathering everything one side. So p square by q square equal to cos to the power 4 by sin to the power 4, means tan to the power 4 equal to p square by q square. So tan square equal to p by q. Wrong, ulta is right. Clear? Sure. Basic definition. Where does the function this attains the minimum value? Where? I know the answer of this from statistics. It is 1 to 7 ka mean. What is the mean of 1 to 7? What is the mean of 1 to 7? What is the mean of 1 to 7? Someone unmute and tell. So, 4.5. 4.5 or 4? Chalo, I'll explain. The sum of 1 to 7 is total number of terms upon 2 first term plus last term, whole divided by total number of terms. Sum by total number of terms is our answer. 7 got cancelled. Yes or no? 4. So at x equal to 4, they are actually calculating deviation square. In statistics there is a theory. Sum of the deviation square or sum of the deviation will be minimum when the mean xi minus x bar is there. Na? Okay? X bar is mean. Sure? Now you want me to do it by differentiation? I will do it by differentiation also. Required? Chalo. So, what is the meaning of this line? So, the meaning of this line is x minus 1 square plus x minus 2 square plus x minus 3 square, yes or no? This is the meaning, yes or no? Clear? Now, x square, x square, x square, x square 7 times 7x square, say yes. Second term, b square. 1 square plus 2 square plus 3 square up to into 7 square. There is a formula for this, I'll explain, don't worry. And then minus 2ab. So minus first term 2ab, second term 4ab, third term 6ab, and likewise it will go minus 14x. Yes or no? So 7x square as it is, differentiation of sum of square terms is n plus 1, 2n plus 1 whole by 6. So for n equal to 7, It's 7, 7 plus 1, 15 by 6. Understood? 3 2s are, 3 5s are, 2 4s are, 27, 140. Yes or no? Clear? And look here, 2, 4, 6 up to 14. If I take minus 2 common, or the minus 2x common, it is 1 plus 2 plus 3 up to into 7. Yes or no? What is the sum of these 7 terms? So n upon 2, first term plus last term. Clear? 28. So this is negative 56x. Understood the function? Yes or no? So the function is 7x square minus 56x plus 140. How do we find the maxima minima? So we will say, sir, we will differentiate. So y dash equals to 8x minus 56. Sorry, 14x minus 56. Yes or no? Right? If I put it equal to 0 at x equal to 4, I am getting only one critical point. Okay? That's a lengthier solution. Fine? Now, understand mod. Very, 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 very important. So, some notes. For mod x, the minimum value is at x equal to 0. And there is no maximum value. Clear? The definition of mod x is x for x greater or equal to 0 and minus x for x less than 0. Okay? So now look at this question. The function attained its maximum value at x equal to 3. Now at x equal to 3, what is the answer? So when I put x equal to 3, this is the definition which follows. Yes or no? Clear? Fine. So if you see this, these two, this function is written for 0 to 3. Yes or no? Tell me yes or no. Bas, you have your answer. As soon as you see close bracket and you are not able to find the critical point, then you have to check the boundary conditions. Yes or no? There are two boundaries, 0 and 3. If you put x equal to 0, your answer is 1. If you put x equal to 3, your answer is 4. So yes, its maximum value is coming at x equal to 3 and local minimum value is coming at x equal to 0. Both the statements are correct. Yes or no? Good. Next. Consider the function. So first box becomes 0 when? At x equal to 2. Second box becomes 0 when? At x equal to 3. And third box becomes 0 when? At x equal to 4. As soon as this kind of question will come, you will divide the function behavior on a number line. So you have 2, 3 and 4. No other point? Yes or no? Good. At what value of x does the function attain minimum value? Okay. What is the minimum value? Are we ready? So understand what all I am saying. For any number less than 2, like 1, this is negative, this is positive, and this is positive. Yes or no? So listen what I'm saying. In this area, okay, the value of the function is negative x minus 2 plus 3 minus x plus 4 minus x. Understood? Between 2 and 3, I'm not telling you how to crack this function. Then it's solve it. Sure. Next is 2.5. If I put 2.5, this is coming positive, this is coming positive, and this is coming positive. All three are coming positive. So means for x between 2 and 3, it is x minus 2 plus 3 minus x plus 4 minus x. Understood? Now I am going between 3 and 4. So for x between 3 and 4, 3.5. 3.5 this is positive, this is negative, and this is positive. X minus 2, negative 3 minus x, positive 4 minus x. Here, for x between 3 and 4. And then for x greater than 4, this is positive, this is negative, and this is negative. Here, it is coming what? X minus 2, negative 3 plus x, negative 4 plus x. Understood how to create a function? Now you have got 4 functions you can create, but here you don't have to do it exactly. Why? I'll explain. There are 4 options. Yes or no? Put them and get the value of the function. So if I put x equal to 2, I am getting 0, 1, 2. 3 is the answer. When I put x equal to 3, I am getting 1, 0, 1. 2 is the answer. When I put x equal to 4, I am getting 2 plus 1 plus 0. 3 is the answer. When I put x equal to 0, I am getting 2, 3 and 4. 9 as the answer. So the function attain minimum value where? At x equal to 3. And what is the minimum value? 2. Understood? Sure? Clear? This was to make you understand how to create the function. Okay? Sure, how to break mod. Fine? Sure. I hope it's clear. Maxima and minima is clear, yes or no? Increasing, decreasing, maxima, minima is clear. Fine? Okay? Bye.
Thank you, sir.